Inverse trigonometric functions, 4-6. So just to quickly think about sine inverse again, or cosine inverse, or any of our inverse trig functions. Remember, when we have an inverse function, we say this is the inverse of sine. So if a sine of an angle gives us the trig ratio of the sides, it gives us this ratio of sides of the triangle, then this one is the other way around. We start with the ratio of the sides of the triangle, and then it gives us the angle. So it's going to gives angle when you have ratio of sides. And then one more thing that I just want to add that maybe you've never thought about is if I had sine raised to the -1 power, that's different, okay? This is going to be 1 over the sine of x, which is going to be the cosecant x. So basically it's different from this, different than this. Than this. All right, so quickly just to look at these inverse trig functions and where they happen, we really have to restrict where these functions happen at so that we don't have more than one answer. So we should know by now when working with trig functions that if I take, say, the sine of 30, or if I go over here and do a sine of 150, I'm going to get the same answer, and I don't want that, right? We know that we need to restrict things because we can't put in a number and then get 2 answers out, basically. We want it to be a function. And so with sine, the way we restrict that is we say it can only happen in this region here. So sine inverse is going to go from negative pi over 2 to pi over 2. So that's what our answers are going to be. They're going to be between those two, which is from negative 90 to 90. So if we're taking the sine inverse of something that is positive, it'll be here. If we're taking the sine inverse of something negative, it's down here. Our domain and our range. So our range is really that angle is from the negative pi over 2 to pi over 2. And I'm going to use the interval notation. And then the domain itself is going to be that ratio of sides. And when we divide those out, those are always between -1 and 1. So cosine is going to have the same domain and range. Actually, it's not. It's going to have the same domain, but a different range. So for cosine, we're looking at it being from 0 to pi, or 0 to 180 degrees. And it would be positive in quadrant 1, negative in quadrant 2. Let's see, in our range, let's write that down, 0, comma pi. These are those hard parentheses instead of soft because we're actually including 0, we're including pi. Last one is tangent inverse. So tangent inverse, our answer is going to be from negative pi over 2 to pi over 2. So this one's like sine. And it'll be positive here, negative here. And I guess what I'm really getting at with the positive and negative is not just the answer that we're given that I'm talking about with tangent. I'm talking about that value of x, whatever ratio of sides we're starting with. If we start out with a positive ratio of sides, we're going to go to quadrant 1. If they give us something negative, we're going to be down here. And that might make cosine make a little more sense. So if they say, find the cosine inverse of -1/2, I'm over in quadrant 2. We will do a bunch of examples on these. So domain is from negative infinity to infinity for tangent. Remember, tangent's the one that's always a little bit weird. And then this one, we're not going to include the pi over 2 or negative pi over 2 with our range, because then we would have something that's undefined. So these are the kinds of problems that we're going to be doing. Oh, you know what? I think I skipped an example. Or maybe I didn't. I guess we're on example 2. So I have a cosine inverse of 1, so I'm going to make it 1 over 1. So now I've got a fraction. So if I'm looking at cosine, I have x over r. So this is my x side. This is my r side. So that means that when I draw this out, because they're both positive, I know cosine's either here or here. Since it is positive, it's going to go in quadrant 1. I label my x side 1 and my y side 1. And then hopefully I recognize that special triangle. My third side would be square root of 2. And I know that that's a 45-degree triangle. And so my cosine inverse of 1 would then be 45 degrees, or pi over 4. We should add in radians here. And if we're going to label with radians, we can have both radians and degrees, but we shouldn't just have degrees. So I'm going to also write pi over 4 here. Arc cosine is another name for cosine inverse, and I'm doing the cosine inverse of negative square root of 3 over 2. So again, cosine is x over r. So these are my x over r's, and I'm looking for my angle. So if this is negative, I know that cosine is either in quadrant 1 or 2. Because it's negative, we're going to build it in quadrant 2. And so my x side would be negative square root of 3. And the r side is 2. So I know to put the negative with x because r would never be negative. And then hopefully I recognize that the third side's 1. So that means this would be a 30-degree angle inside. But what I really want is this angle here. So this angle would be 180 minus 30, which is 150 degrees. And so then I would say that the arc cosine or cosine inverse, same thing, of negative square root of 3 over 2 equals 150. If I say 30, I would be wrong, because 30 would be an angle in quadrant 1, and I don't really mean that. I mean that this has to have a negative. It needs to be in quadrant 2. So it looks like my example 1 for some reason went missing. I don't know what happened to that page, so I'm going to add in a page. We'll do that really quick. Same directions for example 1, but we're working with sine instead. So A is the sine inverse of square root of 2 over 2. So this is kind of a weird one because I don't have a triangle that I can think of where I've got a square root of 2 and a 2. I have a 1, 1 square root of 2, but I don't have a square root of 2 and a 2 side. And I don't even come up with one where the radius is 2. So the other thing I notice is that the numerator and denominator are both 2's, they match. And so that gives me kind of a clue that I need to unrationalize this. And I'm going to unrationalize it by multiplying by square root of 2 over square root of 2. Because I don't want a radical in the numerator, I want it in the denominator. So square root of 2 times square root of 2 is just a 2. And my denominator, I have 2 square roots of 2. So this is really just the same thing as 1 over the square root of 2. And that is something that I recognize. So sometimes if you get a weird thing that you've not seen before, and especially when those numbers match, we are going to unrationalize. So what I really want to find is the sine inverse of 1 over the square root of 2. And this looks far more familiar to me. So y side, r side, because this is positive, I will be building a triangle in quadrant 1. So all of these problems require a picture. My y side is 1, my r side is square root of 2, x is also 1. This is 45 degrees or pi over 4. And so my sine inverse is going to equal pi over 4. All right, and then b here, and I didn't even write example 1. B here was supposed to be the sine inverse of negative 2 pi. So this one looks kind of weird. So I want to always take and make something into a ratio. So I'm going to put it over 1. That means my y side would be negative 2 pi. My r side would be 1. It's negative. So I would build this triangle in quadrant 4. Because remember, sine is either 1 or 4. So my y side would be negative 2 pi. My r side is 1. So I could find my third side with Pythagorean theorem. But there's already something here that's kind of weird, right? So the hypotenuse, negative 2 pi, would be like negative 6.28. The hypotenuse needs to be the longest side. So I don't have a triangle that really works here. So that's a clue. Another clue is that when I think about what we wrote down for our domain for sine inverse, our domain was from -1 to 1. And -2 pi is way outside of that. It's -2 pi is not within that. So this is just going to be, this does not exist. So watch out for stuff like that. And then our last one here, arc sine, which again just means sine inverse of negative square root of 3 over 2. So this one's negative. Again, that means build it in quadrant 4. My y side is negative square root of 3. R side is 2. So hopefully remember that this third side is going to be 1. So the 30 is across from the 1. That means the 60 is across from the square root of 3, which is the same thing as pi over 3. But remember, because we don't list this as the angle that's going all the way around and stopping there, we just use these as negative angles. So this is going to be equal to negative pi over 3. So arc sine of negative square root of 3 over 2 equals negative pi over 3. All right, so example 3 is right where it's supposed to be. So now we're looking at tangent. So you can tell there's kind of a method here. We're looking at all these different trig functions. So tangent inverse, it's positive. So quadrant 1. And again, I don't recognize a triangle that has sides that are square root of 3 and 3. So I want to unrationalize. They match. That's my other clue. You do not have to show the work for this if you know the answer. So for example, I would look at this and just write down an answer because I've done a lot of rationalizing. I know what it was to start out with. But if you need to show the work, show the work. So square root of 3 times square root of 3 is just a 3, and my denominator 3 square roots of 3, which is going to reduce to 1 over the square root of 3. So that's what I'm going to find the tangent inverse of. And those are familiar triangle sides. So I have my y side and my x side. So it is positive. That means quadrant 1. So my third side is 2, my radius. Across from the 1 is 30 degrees, which is pi over 6. And so my tangent inverse is going to equal pi over 6. Next one, arctan of 1. Remember, arctan or arc cosine, arc sine, whatever that is, it just means inverse again. So this is the tangent inverse of 1. I'm going to make this into a ratio by writing it as 1 over 1. That means my y and my x are both 1. It's positive, so it's going to go in quadrant 1 again. So what triangle has a y and an x that are both 1? Well, the third side would be square root of 2. And so I would have a 45, 45, 90, 45, or pi over 4. And so my tangent inverse is going to equal pi over 4. You can do degrees and radians, but because we're doing our answers in radians, we have to have the radians. So the degrees are extra. You can also do those, but we can't just do degrees by itself. So now we're going to look at what happens when we combine these. So I have like a sine and an arc sine here. So first, arc sine of 1/2. This means I'm going to find an angle. And then I'm going to do sine of that angle. So these are kind of the steps that we're going to follow. So my answer is going to be a ratio of sides. So I find that it's really kind of helpful for students to think that through. What's going on? What should their answer look like? So first I'm doing the part that's inside my parentheses. So that means a sine inverse of 1/2. It's positive, so quadrant 1. So my sine is y over r, so this is y over r. So 1, 2, third side is square root of 3. So I am across from the 30-degree angle, which is pi over 6. And so my arc sine of 1/2 is pi over 6. So that means my next step, maybe I'll put this over here on the right where I can actually have some space now. I can replace all this stuff in the parentheses with pi over 6. And now when I go to do the sine of pi over 6, I would draw that triangle at pi over 6 degrees on my unit circle, but I already have the triangle and my sine is my y over r. So that would just be 1/2. So this is one of those problems where it kind of makes sense after you see it, but if you'd been asked to just do the math without showing any work, you might not have understood right away what was going on. So because sine and sine inverse are inverses, they should cancel each other out. We should end up with what we started with. So this is because of inverses. So yes, we started out with 1/2, we end with 1/2. Because we took 1/2, we applied one function, we did the inverse, we should stop back at 1/2 afterward. That should be our final answer. So here's two more where we're combining that are not so easy. Now that you've done one, right, you're watching for like cosine and arc cosine, but that's not what we have. And these are really strange because we have variables. So that makes them extra fun. So I'm going to make this an x over 1. First, I'm going to find the arc cosine. That means find the angle, and then I'll be taking the cotangent of that angle. So I am going to end up with a ratio for my answer again. It's positive, so I'm going to work in quadrant 1. So my, let's see, cosine is x over r. So my x side is going to be x. My r side's 1. So I can think about that shortened version of the Pythagorean theorem where I would now do 1 squared minus x squared and take the square root of that, which is just 1 minus x squared. So I have 3 sides, but they're kind of weird, right? And then I could call this theta, or I could call it u, or I could call it whatever. So I did the arc cosine and I found this angle in here. I think the book does u, so we're going to call it u. So we looked at just this part. So we said that the arc cosine of x, got to have 2 c's in there. We said that that was going to be an angle u. And we went through and we set up this whole triangle for that based on the cosine of u being x. And then we got all this stuff. So now I want to find the cotangent of that angle. And I don't really know what the angle is, but I don't care because I'm not needing to find the angle. In the end, I want to have a trig ratio. So now we're going to find the cotangent of u. And this is just extra stuff that your book does. I don't really care if you write it down. Extra stuff your book does. The important thing is we recognize we could put anything inside here, theta, they use u, but because our answer is not actually an angle, we don't care. Our answer is going to be a trig ratio. So now when I do my cotangent, that's going to be let's see, cotangent would be x over y. So that's going to be x over 1 minus x squared, square root of. So then I want to rationalize it. And so my final answer will be x times the square root of 1 minus x squared all over 1 minus x squared. This one worked out kind of nice because the x side was actually labeled x, but these can get really weird where your cotangent is your x over y, but your x side is labeled y and your y side's labeled something crazy. So you really have to be careful with these. It kind of adds a level of trickiness to them. So in the next one, we're finding the sine inverse first of this ratio of sides, and then we'll find the tangent of that. So again, this is going to be another one where we don't really care about the angle. We're just trying to build the triangle so we can do the tangent. So I'm going to go ahead and do sine inverse. This is positive, so quadrant 1. So sine is y over r. So this is what I'm talking about. Now my y side is going to be x, and my r side is going to be square root of x squared plus 9. So the way the Pythagorean theorem works, I have something squared plus x squared, and then I do the square root of that. So here's the x squared, here's the something squared. So that tells me that this third side is going to be 3, because 3 squared plus x squared square root would be my hypotenuse. So for a lot of these, you're going to be able to just kind of look at it, and if you think for a minute, you're going to be able to get that third side. So now I have found the sine inverse. Now I need to do the tangent. And I could call this u, I could call this theta. And so my tangent is going to be my y over my x. And when I say y, I mean vertical side, not the one labeled y, because there isn't one labeled y. So my y side is actually called x, and then my x side is 3. So that's going to be x over 3. So again, be really careful on these just because of the sides and the way we're labeling them. So this last stuff, the last 2 pages, I think are really the heart of what we want to be able to do with numbers. We want to be able to combine these 2 different trig functions. And then when there's letters for your sides also. So that's basically what your test is on. And there are 3 or 4 of those. I am not sure at this point. But that's the kind of problems that we really want you to be able to work on and want you to be able to get good at. And so I will give you lots of examples on the homework.